This is a tutorial on circles as conic sections. When we discuss conic sections, we're talking about cutting a double cone with a plane. Now, if we cut or intersect our double cone with a plane, so this plane is perpendicular to the axis that creates our cones, or passes through the center of our cones, then we would create a circle. Now, the standard form for a circle is x squared plus y squared is equal to r squared. But this standard form assumes that the center of your circle is at the origin. If the center of your circle is not at the origin, it's at some other point, then you use the standard form of a circle where x minus h squared plus y minus k squared is equal to r squared. This equation assumes that the center of your circle is at the point hk. Now r is just some constant that describes the shape of your circle or the size of your circle. An example of an equation of a circle would be x squared plus y squared is equal to 36. Our r in this case would be 6 because 36 is 6 squared. Another example would be x squared plus y squared is equal to 9. Here in this case our r would be 3 because 9 is 3 squared. Now, if I intersect a double cone perpendicular to the axis of these cones, and we create a circle, then if I look down onto my plane, and I look through the cones to see where my plane intersects my cone, then I would see a circle, and I could imagine a coordinate axis on that circle. If I took that coordinate axis in that circle and I put it on a graph, it would look something like this. This blue ring here is our circle. Every point on this circle is the same distance away from the center of the circle. And that distance between our center and every point on that circle is called our radius. So every point in blue on this circle is the same distance to the center, and that distance is r. R, in our standard equations, is our radius. So if we had x squared plus y squared is equal to 36, that would mean our r is equal to 6, and our circle is described where every point is a distance of 6 away from the center. So let's write the equation of a circle with the center at 2, -3, and with a radius of 5. Now our center is not at the origin. So since our center is not at the origin, we're going to use the standard form of a circle that looks like x minus h squared plus y minus k squared is equal to r squared. Now my h is the x coordinate of my center, so in this case 2. K is the y coordinate of my center, so in this case -3. And then r is my radius, 5, so that would be my r. So if we plug all this stuff in, we'll have x minus 2 squared plus y minus a -3, and that's all squared. And that's equal to our radius, which in this case is 5, and that's squared. If we simplify this, we have x minus 2 squared plus y, now minus a negative would be plus 3 squared, and that's equal to 25. So this is the equation of our circle. And all we did is take what we know about the circle and plug it into the standard form of our equation. Now let's try graphing some circles. Here we're given x squared plus y squared is equal to 36, and we want to graph this circle. Now because this is x squared and y squared, that means that our center is going to be at the origin. 36 is our r squared, so that means r is going to be equal to 6, because 6 squared would be 36. So if we're at the origin as our center, and every point is 6 units away from that center, then we can go to positive 6 on the x, because that would be 6 units away from our center, And we could go to negative 6 on the x-axis because that would be 6 units away from our center. We could also go to 6 on the y and negative 6 on the y because both of those would be 6 units away from the origin or the center of our circle. Now if we connect these 4 points with a smooth rounded curve, our circle would look something like that. Now we were able to graph this just because we knew where the center was and we knew what our radius was. Now let's try graphing our next equation. Here we have x minus 2 squared plus y plus 3 squared is equal to 36. Here again, our radius is equal to 6. But our center now, that's at the point 2, negative 3, because this is h and that one's k. So if we go to our center, 2, negative 3, that's right there, and this is the center of our circle, and every point on this circle is 6 units away from that center. So if I'm at 2, negative 3, I need to find all the points that are 6 units away from that. So 2, negative 3, 6 units away would be 8, negative 3. Negative 4, negative 3 would also work. I can also go in the y direction, 6 units. So from 2, negative 3, I would go up to 2, positive 3. And from 2, negative 3, I could go down to 2, negative 9. Now I got several points here and I can connect them with a smooth round curve. And my circle would look like that. Notice that these circles are exactly the same size. Even though our equation contains these h and k numbers, all that does is translate or move our circle over 2 and down 3. And every point on this circle is moved over 2 and down 3. Over 2 and down 3. But the fact that we translated our circle has no effect on the radius value. Now lastly, let's try to find the center and the radius of a circle when we're just given the equation. And this is a complicated equation. We have x squared plus y squared plus 6x minus 4y is all equal to 36. Now because we have x and y squared, but we also have linear terms in x and y, we're going to have to complete the square 2 times, once for the x and once for the y. I'm going to put my y terms together and my x terms together, so I'm going to write this as y squared minus 4y plus x squared plus 6x, and this is going to be equal to 36. Now let's look at just our y's for right now. If I wanted to make y squared minus 4y a perfect square, I would have to add 4. But if I add 4 to this side, I have to add 4 to the other side. So we can do that. This will become y squared minus 4y plus 4 plus x squared plus 6x, and that's going to be equal to 40. Now I can rewrite this y squared minus 4y plus 4 into its factored form. This is y minus 2 squared. Now this is still adding x squared plus 6x, and it's still equal to 40. But I've completed the square and turned my y coordinates into a perfect square. Now we look at just our x terms. If I want to make these two x terms into a perfect square, I would have to add 9. If I do that, I'd have y minus 2 squared plus x squared plus 6x plus 9, and that's equal to 49. Now x squared plus 6x plus 9, I can write that as x plus 3 squared. So what I really have here is x plus 3 squared plus y minus 2 squared, and that's equal to 49. Now notice that this is in the standard form of x minus h squared plus y minus k squared is equal to r squared. In this case, my h is a negative 3. My k is a positive 2. And then my r, well, the square root of 49 is 7, so my r is equal to 7. So that means my center is the point, -3, 2. And my radius, well, r is equal to 7. And that completes the tutorial on circles as a conic section.